Okay, so in the previous lecture, in the previous classes, we studied about different laws, right? So Boyle's law, Charles' law, Avogadro law, combined gas equation, and the density and the ideal gas equation. These things we already studied in the yesterday's session. For the today's session, we are going to take some important topics which will actually come in the exam, because this is the application part of that ideal gas equation part, right? So I'm just taking a screenshot for the topics, what topics we will do. So these are the topics which we are going to cover today, and inshallah we will be able to finish the chapter 10 today. Okay, and inshallah for tomorrow we are having one session for chapter 5, and we'll finish inshallah chapter 5 in one session only. For Saturday and for Saturday inshallah we will finish chapter 6. For Sunday we are going to have two sessions. I know that you will from Sunday you will have only your chemistry final. So one session might be in the morning and one session might be in the evening. I will confirm you the timings of both sessions. So we will be able to finish chapter 7, 8 and most probably chapter 9 up to Sunday. And after Sunday we will solve the previous year questions from these chapters which we will finish. And chapter 1, 2, 3 and 4, these chapters are not too too difficult. They are very very easy. So when we will do the practice of the previous year questions and also the Alex questions, so inshallah you will be able to understand the basic things behind the chapter 1, 2, 3, 4. It's not a very big deal, so don't worry about that. Okay, it's very simple, very very simple. Okay, if you find any problem, anything while studying, all of you have my WhatsApp number and you will be able to ask me anything regarding that, right? So second, okay. So for today we will be doing first by the calculating the required volume for the gaseous reactant, right? How much volume for the gaseous reactant needed to do a reaction, determining the amount of the reactant consumed using the change in pressure. We will see what is this. And the last one is the predicting the volume of the gaseous product, right? One thing you already know, that for example I have a small question for you. Okay, because most of you have already finished the previous session. A question for you from the previous session. For example, I have hydrogen gas, and let us consider I have 2 gram of hydrogen gas. I want you to tell me how much liters of hydrogen gas is it? How much liters is it? Can you please do this? If you don't know how to do this, just it's not a problem. It's not a big problem. If you don't know, you don't know. That's it. If you know, just try. And tell me how we will calculate the volume of this gas. Any solutions? Amna, Nora, Noor and Saif. Any solution? What do you think? How you will be able to solve them? Very good. The first thing we will do is the conversion of the grams to moles. Okay, then we will directly convert moles to liters. That's it. Okay, moles to liters. One second. Okay, so the first part that we will convert gram into mole. How we will convert the gram into mole? For these types of the questions, okay, always remember, just convert everything to the moles. When you will be able to convert into the moles, well, that will be very easy, right? See, for example, we know that we are having H2 gas. What is the molecular mass of H2? For one hydrogen it is 1, and it will be multiplied by 2, so it will be 2 grams per mole. It is already 2. You know that given mass divided by molar mass is equals to number of moles. So 2 divided by 2, it will be equals to 1. So it is 1 mole. The number of moles are 1. Now what you will do, you will just convert it to the liters. Very simple. How? First thing, you must need the temperature. If the temperature is not written here, it means the temperature is a normal temperature. It's STP. STP. I told you the meaning of STP. The pressure equals to 1, temperature equals to 2733 Kelvin. Okay, so for 1 mole, the volume as STP, I told you in the last class, it was 22.4 liters. Steps how I got this value. I use the formula PV equals to nRT. I know the pressure, it is 1. I know I don't know the volume. Number of moles I know. R, for R, yesterday I told you, for every R in this type of the equation you will use 0.082. Okay, for T is 273. It should be in Kelvin. You remember that it should be in Kelvin only. If it is not in Kelvin, just convert it into the Kelvin. You will never use it in the Celsius or Fahrenheit. Okay, so now the answer will be this. So if the gram is given to you and you want to calculate in liters, first step is to convert it to the number of moles, and after that just convert into the liters. This is the very easiest thing. Okay, now I'm giving you one more question. Question for you. Okay, my voice is coming, my voice is fine. Okay, so yeah, the question for you is calculate volume of 14 gram of nitrogen gas at pressure is equal to 1 atm and temperature equals to 300 Kelvin. Please calculate fast and tell me what is the answer. Please calculate fast and tell me what will be the answer. For one nitrogen, it is the molar mass is 14. For two nitrogens, just calculate. Saf and Noor, just tell me if you are finding any difficulty. First tell me, did you see the previous session, the yesterday's session? Did you check that? Noor and Saf. Oh, okay. How about the Noor? And but are you able to understand whatever I am teaching? Or you are finding some difficulty? Saf? What this no means what? Achha, okay, everything is good, fine. Okay. Okay. I think I should message him. Okay. Fine. So, did you check the answer? How you got the answer? How much volume of nitrogen gas you got? First tell me which formula should I use? Which formula should I use? You always will use PV equals to an RT. Pressure, volume, number of moles. This is constant and this is temperature. Okay. What is the pressure? It is 1. You have to calculate the volume. How much number of moles you got? First you have to calculate the number of moles. Okay, as I told you, the number of moles is equals to given mass divided by molar mass. The given mass is 14 multiplied by 2 and 14, and the molar mass is 14 multiplied by 2. 14 will be like this. It will be 0.5 moles. So for moles it will be 0.5. For R it is 0.082 multiplied by 300. Now it's just a simple calculation. 150 multiplied by 0.082. What answer you got? Can anyone tell me the answer? How much answer you got, guys? Very good. 12.3. The answer is 12.3. Great. Now, tell me one important thing. Do you know the chapter of moles, how to calculate the moles concept, and limiting reagent theoretical yield? Do you know that? Do you know the chapters of theoretical yield, limiting reagent, like that? Do you know? Very difficult. I understand. Amna and everyone. Okay, very difficult for everyone. Okay, no problem. From today, inshallah, it will never be your problem. I'm telling you how I perform this and how I finish the elix so fast. See, let us consider I have a reaction N2 plus H2 and it is giving you NH3. Okay, the step 1. The step 1 is balance the equation. Okay, so I have to balance the equation, yani 1 here, 3 here and 2 here. It is balanced. So step 1 finished. Step 2. Convert all masses into moles. All masses into moles. Okay, so let's try to have some masses. For example, I have a question. I have 14 gram of nitrogen gas, and let us consider 12 grams of hydrogen. Yes. Okay. Now I want you to calculate the number of moles of N2 and H2. Please. How much moles of N2 and how much moles of H2 are there? For the hint, I am telling you the molar mass of nitrogen is equals to 14. Of one nitrogen is 14, it is N2. And for one hydrogen, it is 1. So please calculate the number of moles for nitrogen, for hydrogen. Okay. How about Saif? Okay, great. Same answers. So 0.5 mole here, 0.5 mole here, and 6 moles here. C. You have got the moles right. Okay. So let's come back to this equation. I am writing the moles now. Okay. I am writing the moles now. I have 0.5 moles of nitrogen and 6 moles of hydrogen. I want to calculate who is the limiting reagent. The first question is, I want to calculate who is the limiting reagent. Now see, very what we say, very important topic, right? So this one will come here also, and also in the chapter 4 or chapter 3, whatever it was. Okay, see how it was. 1 mole of nitrogen, this is either a mole or a molecule. This coefficient is either a mole or a molecule, not gram. It is never be gram. Okay, 1 mole or yani 1 mole of nitrogen gas is making 2 moles of ammonia. Oh my god. 1 mole of nitrogen is making 2 moles of ammonia. It means that, for example, I have 5 moles of nitrogen. So how much mole of ammonia? Double. 10 mole of ammonia will make. If I have 2 mole of nitrogen, obviously the 4 mole of this. If I have 0.5 mole of nitrogen, tell me how much mole of ammonia will form? Tell me. If I have 0.5 moles of ammonia of nitrogen, tell me how much moles of ammonia will form. I told you, if 1 mole of ammonia is making 2 moles of ammonia, if 1 mole of nitrogen is making 2 moles of ammonia, if they are 2, it will make 4. If they are 5, they will make 10. If they are 20, it will make 40. The difference is double. So it means that if I have 1 mole of nitrogen gas, it will make double of ammonia. Very good. The answer is 1. Answer is 1, because 0.5 multiplied by 1 is multiplied by 2 is, it's 1. So according to nitrogen, see, according to nitrogen, the ammonia will form how much? 1 mole. This is according to nitrogen. Now see here. 3 moles of hydrogen is making 2 moles of ammonia. Okay, 3 moles of hydrogen is making 2 moles of ammonia. Tell me how much ammonia will form if I will take 1 mole of hydrogen. Okay, tell me how much moles of ammonia will form if I will make 1 mole of hydrogen. See, 3 moles are making 2 moles, so 1 mole will make 2 divided by 3. Simple. I did what I did, you know what I did? I divide everything whatever I took in the starting. See, for example, if I talk about 1 nitrogen, so 1 mole is making 2 mole. So I just divide everything by this. Okay, here 3 mole is making 2 mole. I will just divide everything by this. So 1 mole equals to 2 by 3 moles. How it 1 mole? I mean 3 by 3 and 2 by 3. Did you got my point? 1 mole is making 2 by 3 moles of ammonia. Did you understood this point? Did you understood this point? How the 1 mole of hydrogen is making 2 by 3 moles of ammonia? Right? So now see. If 1 mole of hydrogen is making 2 by 3 moles of ammonia, now I have 6 moles here. So what I will do now, I will multiply 6 on the both side. Multiply 6. So it is 6 moles is given by 4 moles. So hydrogen will give 4 moles of ammonia. Okay, this is the product of nitrogen and this is the product from the hydrogen. Tell me, my friends, who is making less ammonia? Who is making less ammonia? Safe. Tell me, who is making less ammonia? Less number of moles of ammonia. Obviously nitrogen. It means that yes, nitrogen is the limiting reagent. This is how you will calculate the limiting reagent. Now nitrogen is the limiting reagent and hydrogen is the excess reagent. Hydrogen is the excess reagent. It means that it is a lot. Only small part will be reacted and everything is never be reacted. Okay. Now if I got this thing and now I got the point that the small product, whoever will make the small amount of the product, that will be the limiting reagent. This thing I got. Now I got 1 mole of ammonia. Okay, 1 mole of ammonia will form. Can you be able to tell me how much volume of ammonia will form at STP? How much volume of ammonia will form at STP? Do you think you can be able to do that? Think. Wallah, if the moles are given, you can tell the volume also. This thing come in this chapter. The starting part, the part of the limiting reagent and theoretical yield, it was the part of previous chapters. And this thing, from whatever product you got, the number of moles, convert this into volume. That is the part of this chapter. Okay, the final trick to solve these types of the questions is you always remember that the mass is always given. Okay, so just convert these mass into the moles and then convert these moles into the coefficient. How? 1 mole is making this moles, then the given moles will convert into that, okay, and then this coefficient will be the moles. Now these moles can be converted into the volume with the help of PV is equal to nRT. Did you got the point? Every mass will be converted into the moles, then these moles will be converted into the moles of the products, and finally the volume. This is how you will be able to do them. Also it can be given oppositely. Like for example, volume is given. See, volume is given and you have to calculate mass. What you will do? First convert the volume into moles, then convert these moles into the moles of the product, and then moles can be converted to the masses very easily. Okay, this is the concept map behind these types of the questions. Okay, let's try one question. Let's try one question. One second. Let me open the Alex one second. This question, wallah, very hard question for everyone. For everyone, this question, wallah, very hard. I don't know why you think it's hard, but wallah, it's the easiest one. How many of you think that this question is very hard, one of the hardest part of the Alex? How many of you think like that? Solving for a gaseous reactant. Do you think it is hard? Let's see. First read the question. Combustion of C3H8. You already know that the combustion means burning anything with oxygen. Okay, so C3H8 is burning. Okay, it means it is reacting with oxygen. Okay, and whenever these types of the products will burn, you will always get two things: carbon dioxide and what? CO2 and H2O. What was the step 1? Guys, tell me, what was the step 1 to do these types of... Alex question is different than... I know Alex question is different from the final one. I know, my friends. But they are just... at least you should know the concept behind every question. Okay? I will solve the final questions also of the previous year. Also from UA University of the same course. Don't worry, inshallah. And you will be able to do them. It's my bet. Okay, you will be able to do every question regarding that. So don't worry. I know the Alex question is very different from the final one. But most of them, it's like them. Okay, so tell me, C3H8, what was the first step to solve these types of the questions? Amina, are you there? So what was the first step? Step 1 is balance the equation. So the first, what you will do, the balancing. Yes, balancing the equation. How we will balance them? Balancing the equation, it will be like 3 carbon dioxide and 4 water and 5 O2 and 1 is this is now finally balanced. Okay, if you are facing the problem how to balance the equation, we will talk about that. Okay, don't worry, but right now our focus is different. Our focus is on how to solve these questions. Okay, so the first part is solved, and you have to just put the physical state of the symbols. So it is simple. It is the gaseous propanes. Just put gas, and oxygen is also gas. Carbon dioxide is also gas, and here it is also from the gaseous water, so it will be gas. Finally, the first part is fine. Now we will come to the second part. Now see, suppose 100 gram, it is 0.100 kilogram, or you can say 100 gram of propane. It means you are having 100 gram of this. At pressure is this, temperature is this. Calculate the volume of the carbon dioxide in liters. Guys, calculate the volume in liters. Volume, we have to calculate the volume. Wallah, the simplest thing. First, calculate the number of moles of this. Tell me, what are the number of moles? What is the molar mass of C3H8? It is 44. I'm telling you, it is 44. So number of moles is equal to given mass by molar mass. It is 100 divided by 44. Tell me how much moles you got? How much moles you got? Very good. 2.2. 2.2. Now see, if the 1 mole is making 3 moles of carbon dioxide, so tell me 2.2 moles will give how much moles of carbon dioxide? Tell me. If 1 mole is making 3 moles of this, then tell me how much moles of carbon dioxide will form by 2.2. Very good. 6.6. Very good. So the number of moles of carbon dioxide is equal to 6.6. Now if they are 6.6, the formula to calculate the volume is PV equals to nRT. If you want to rearrange them, you can also rearrange it by V is equal to nRT by P. Number of moles is 6.6. R is 0.082. Temperature, what is the temperature here? 13 degrees Celsius. So for 13, 273 plus 13, it will be 286, and divided by 1. Whatever answer you will get, it will be in the liters. And finally, you have solved, wallah, the hardest question of whole Alex. It was easy. Now tell me, do you think it is easy? Wallah, yes, it is easy. Okay, so don't worry, nothing is very difficult, wallah. And also, one thing you also tell me, can you be able to solve the questions of limiting reagent and the theoretical yield right now? Can you be able to solve them? Okay, so okay, fine. uh, Noor is telling me that she was replying to Amina only, and I was not able to see her messages. So Amna, you didn't tell me Noor was messaging you. Okay, well now you tell me please that both of you, did you understood? Can you be able to solve the questions of the those one, the limiting reagent and everything? Both of you, do you think they are easy now? Okay, for both, great, it's very nice. See, this confidence, I want everyone this confidence that yes, we can be able to this type of the question. Great. Okay, so let's move forward. Let's move a bit forward. Okay, now the last question for the last part for the today's sessions. The last one is Dalton's law of partial pressure. Dalton's law of partial pressure. See, what does it mean? It means that the pressure of every gas for those gases who are not reacting with each other, the pressure of those gases, it will nothing but the addition of both. The addition of both. Like the total pressure of the container having the two gases, it will be simply P1 plus P2. Halas. That's it. Okay? Simple. For this type of the questions, for these, especially these types of the questions, you must know what you know. You must know how to calculate the number of moles and mole fraction. Mole fraction. Okay? How to calculate the mole fractions of that. What is the mole fraction? The mole fraction is the number of moles divided by the total number of moles. Halas. Okay? Let's I'm giving you the question. I have 2 moles of H2 and 3 moles of N2. Okay? 2 moles of H2 and 3 moles of N2. Tell me how I will be able to calculate the mole fraction for the hydrogen and mole fraction for the nitrogen. See, the mole fraction for the hydrogen, it is, I told you, what is the formula for the number of moles? Number of moles divided by number of moles total. So, number of mole total is the moles of first and second. So, for this, it is 2 divided by 2 plus 3. It is 2 by 5. For this, it is 3 divided by 2 plus 3. It is 3 by 5. These are the mole fractions. Very easy thing. Not a big problem. Did you understood? Did you understood what is the mole fraction? For example, now this was a question of moles. If I give you, like for example, 2 gram of hydrogen and 14 gram of nitrogen, first you will convert gram into mole, then mole into the mole fraction. Okay, did you got my point? Did you got my point? Did you got my point finally, guys? My voice is coming. Yeah. Okay. So for the mole fractions, just calculate the total number of moles and just divide it by it. Okay. If the mass is given, the mass can be converted to the moles and then the mole fractions. That's it. Now, for the pressure of the mole fraction, what you should do, for example, I have a question for you. Okay, like 1 mole of hydrogen, 2 mole of nitrogen. Okay, I have this mixture. I want to calculate what will be the pressure. Okay, what will be the pressure for hydrogen and for the nitrogen? Wallah, very simple. You already know. What do you know? See, you know that, sir, PV is equals to nRT. So first you will put N here, you will get the moles of this and you will get the pressure of this, and just put N is equal to 2, everything you know, and you will get the pressure of this, and the total pressure will be equal to P1 plus P2. This is called the Dalton's law of partial pressure. Okay, this is called the Dalton's law of partial pressure. That for those gases which are not reacting with each other, because hydrogen, nitrogen, they never react with each other. Okay, for these types of the gases, the total pressure will be equal to the addition of the both pressures. That's it. Okay, now the pressure total multiply by the mole fraction of A can be either one gas or second gas, any A. Okay, of any one gas, it will be equal to the partial pressure of A. You can write that PA will be equals to P total, and this is called chi. Okay, this is called chi A, and this chi is the mole fraction. Okay, so PA, this is the pressure of A. I want to calculate the pressure of one gas from the total pressure. So it is nothing but the mole fraction multiplied by the total pressure. Okay, now I can say that your chapter 10 is finished and nothing left here. Okay, nothing is left in your chapter 10. Reason. We have covered all the laws of chemistry. Okay, laws of gases. Then we have completed the ideal gas equation. After that, we have completed how to convert from gram or from the for the reactions from moles to the volume, density and ideal gas equation, and the last one is the Dalton's law of partial pressure. Okay, finally, now I want you to go through the slides which was given by your doctor, and just don't study those things. No, you don't have to study everything. Just find the questions inside those slides, and inshallah you will be able to solve each and every question there. It's my promise to you. You will be able to do them. And tell me, my friends, if any one of you can arrange the previous year questions for this for your chemistry, the previous year questions, is anyone is able to arrange that for me, or anyone if you having that, if you can send me that, tell me. Okay, please, both of you, please send me the previous year question papers, and previous year, not the last year, also the last to last year, whatever you have. Okay, like a question bank or anything like that. Okay, I have it from, but not from your university, I have it from UA university, because when I did for the UA university, there was I think 26 students who registered with me for the final exam, and well, they got most of them got I think 48 out of 50, most of them, and some of them also got the 100% correct, but alhamdulillah they got very nice marks. So inshallah you will get good marks also, and you must be at least confident about yourself, whatever you are doing, right? So for today, chapter 10 is finished, and inshallah and wish me good luck, because tomorrow I have my final exam. Okay, wish me good luck. Okay, tomorrow I have my final exam, and see, I'm doing that for you, right? So, and from tomorrow inshallah we will finish our chapter 5. Chapter 5 is thermodynamics. It's not very, I know it's some, for some students it's very complicated, but wallah, for me it will be very easy. Complete chemistry is very easy, nothing is like very, what we say, very difficult or something. Complete chemistry is very easy. Okay, it's like how you are studying and who is teaching you. Okay, so thank you so much for the classes, and inshallah we will join tomorrow at the same time, and inshallah for tomorrow I'll try to make a session a bit longer. Okay, so you will be able to understand more things, and inshallah I'll try to finish chapter 5 tomorrow, complete chapter 5 tomorrow with questions and everything. Okay, if you are having any doubt, you can ask me on WhatsApp, or you can ask me here. Also, I can recommend you one thing, like for example, you are writing everything here in the laptop or in the chat box, no problem, you can write, but also if you can be able to open your mic and you can ask me or tell me the answers, it will be a nice interaction with all of you. Okay, so fine for today inshallah, and have a great night, and ma salam, goodbye.